But that is, I would just say it's a highly volatile sample. You got to be careful. You got to watch getting good at stuff. It'll take advantage of it.
Yeah.
All right, so let's talk about the binomial distribution. I've gone back, same distribution we looked at with Max and guessing his crocs, 1/2. Probability of success is 1/2. Flipping a coin, red or black out of a deck, genders, boy or girl, 1/2. Max putting his crocs on the right feet, wrong feet, probability 0.5. This is what the distribution would look like if you ran dist fill with a sample size of 3. So if you went 0 to 3, it would look like this. There's a 1 in 8 chance, 12.5% chance of no success. So this is me watching Max 3 times versus 10 times. There's a 12.5% chance he'll never get the shoes on his right feet. There's a 12.5% chance he'll get them on his right feet every single time. And then there's a 37.5% chance he either gets it 1 or 2. Okay? What if I watch it 5 times? It looks like that. Notice the probabilities here are starting to come down. We're also starting to add longer tails. Here's the distribution we just looked at. That's the one you guys just graphed in your TIs. Here's Max right here. Notice it's getting harder and harder to get into the tails with every passing curve. It's getting harder and harder to land out here with every passing curve. Here's if I watched him 25 times. Here's if I watched him 50 times. Here's if I watched him 100 times. Now, what do these curves start to look like? Say that again.
The Empire State Building.
Oh, good! Very excellent. Wasn't thinking of that. Well, do you notice how the tails look like they're disappearing? They're not really. Isn't there a chance that if I watch Max 100 times and he guesses at putting his crops on, isn't there a chance he never gets it right? Sure, there's a chance.
It's very, very slim.
It's very, very slim. It's 0.5 to the 100th power, which essentially is 0. It's so small, the cell doesn't even show it. You start seeing when they start showing it right about there, it's extraordinarily unlikely. The most likely outcome, of course, is the average, which is exactly 50 out of the 100 State Building. Very good, very good. But the idea is these curves are beginning to smooth out. You're beginning to see the lion's share of what's happening. Did anybody catch the fact it's only 8% in the middle there? Did you see that? It's an extraordinarily small amount because there are so many bars now, because it's the building. There are so many little bars that need to be added together to make the 100%. When there were only 4 bars back here, these have to add to 100% as well. 12.5, 37.5, 37.5, 12.5. As you start adding more bars, the bars have to be shorter because you've got more of them to make up 100%. So watch that vertical axis right here, friends. The most likely outcomes are happening less likely in the middle. Now, this shouldn't surprise you too much because it's still very likely to land in this region. And that's what 244 spends a lot of time doing, is defining regions versus just defining bars. And I want to start that with these last 2 weeks we have together, is the defining of regions versus just the individual bars. The reason I bring it up is because it shows up in other places. Do you see an Empire State Building in this?
No.
Not quite as steep as the Empire State Building. Do you see any similarities, friends, between that curve and this curve? Give me a similarity. It's almost a bell. It's almost a bell shape. I like that. Good. This curve and this curve. What's the most likely occurrences in this? What would the heights of American women aged 18 through 24? If you had to take a guess at what the average American 18 to 24 woman's height is, would you guess 60.5 to 61.5 inches? Why would you not guess here? Because if you try to balance that, the cookies drop it off like this, as Sarah would tell me. Where's the balance point of this curve? Ish. Yeah, somewhere over here, right? About 65 inches, somewhere in this neighborhood. That's where your hand has to be to balance the cookies. You got a tail over here, very, very tall. You got a tail over here, very, very short. And you've got a predominance of data in the middle, which is the bell shape, the rough average of the bell shape. Boom. How about LDL readings? We looked at this back in the day. Again, roughly bell-shaped data. Where's the average? If you had to give one number for an average LDL? Yeah, somewhere around 5. I think so too. I just got mine tested. I'll share my data with you when I get it back. Here's another one. 100 randoms. IQs. I actually have some data we can play with this one later on. I'm thinking on Thursday we can play with some IQs, some IQ numbers. Notice the similarity in shape of all these distributions. They all look like that Max guessing bell curve. Speaking of Max, what's kind of fun about it is all of these things are bell-shaped in data. Take a look at all these things. Take a look at some of the data sets here.
How's length of human pregnancy?
I got some fun data for that one. Length of human pregnancy is bell-shaped. That means there is an average pregnancy length. It is usually described as 9 months. 40 whatever weeks. I sure there's something about weeks. Right. There's an average. That's often quoted. But the thing is, that average has a plus or minus on it. And the plus or minus, you know what the plus or minus is on human pregnancy? 10 days?
No.
10 weeks.
10 weeks.
Good. That's where it gets interesting. It's not 10 weeks. It's something. We're going to talk about that soon. I'm thinking Thursday soon. But yeah, Sarah, the idea of all of these data sets is there's an average for all of them. For example, actual volume of 15-gallon gas tank in a car. What do you think the average is for a 15-gallon gas tank? It's 15 gallons. Maybe a little bit more. Maybe 15.1, 15.2. But there's also a plus or minus around that. When they machine those things, they're not identical. There's called a tolerance, an allowable difference between them. All of these things have tolerances. Thickness of tree bark on a given tree is not uniformly wide. It varies. But it varies almost predictably. Egg incubation times for chickens. A chicken lays an egg, at least mine, lay an egg roughly 3 days out of 4 or 4 days out of 5. That means they're incubating inside the chicken roughly once a day. But once a day has a plus or minus around it, right? It has a plus or minus. It's got a standard deviation. You've actually looked at it a little bit in this class. Number of chips in Chips Ahoy chocolate chip cookies. Also bell-shaped. It's got an average. They actually advertise it on their bag, I believe. You'll find blah, blah in every cookie. We used to break them up in class, and it makes a huge mess. We used to test that. Size of wine bottle corks cut by a machine. Time needed for employees to complete a certain task. All of these things have an average that's roughly in the middle of a bell. And then it's got these tails that tail off. So for example, sizes of wine bottle corks. That would probably, if I'm guessing, have an empire-shaped building bell curve. Because you've got an average and a very tight tolerance and very, very little room for crazy error. But all of these things are roughly bell-shaped. What's interesting about it is the incredible places that these... Oops, I think I froze PowerPoint. Oh God. Here we go. Start the task manager. Just close the program. I'll start it back up. I wanted to show you one other place. Going back to Sean. Come on now, cancel. There we go. I wanted to show you one other place it showed up. That's great. This is Max, very young at OMSI. If you've been to OMSI, you've seen this. It's a great, great, great machine. It takes little plastic balls on a little conveyor, brings them up to the top, and then drops them in the middle of this funnel. So the balls are released in the middle of this grid. Is a series of pegs that are set up in even intervals. So the balls come down, bounce off the peg. He's explaining it to you. Listen to it. Perfectly clear. Did you get that? Perfectly clear. So what's happening is they're hitting the pegs. There's some randomness going on. There's some randomness going on because they're hitting the pegs and they're bouncing off. Which direction are they bouncing off? It's essentially a coin flip. There's some butterfly effect stuff going on, right? Those balls are spinning at certain rates, but they're very, very random. But look what's happening as they're filling the bins at the bottom. Where are the lion's share of the balls headed? Why are they? This is a shot from later. Max, go check it out. This is the longest he's ever watched anything. Kid's got ADD like I do. He's sat there transfixed with my wife. Notice the middle is filling up more than the tails. Why? Can you explain it? Jen's explaining it very well right now, but she's talking very quietly. You can't hear her. I wish you could hear what he was saying right now. I'm going to hit pause here real quick. So, why are most of them landing in the middle? Any idea? If it's bouncing off the posts randomly, Lydia, what do you think? Why? It's really hard for it to get off to the side. First of all, Lydia said the correct thing. It's dropping in the middle. But it's also bouncing all over the place. So why is it ending up in the middle if it's bouncing around? Say it again, Lydia. It'd be really hard for it to get over here because it would have to keep taking right turns. It's just like Max and his Crocs. The ball essentially is guessing when it leaves the peg. It's flipping a coin to decide if it goes left or right. So it hits a peg, decides left, decides right. On average, it flip-flops. On average, it flip-flops. So for every left, it goes right on average. Now, just like Max, though, just like that distribution for Max, there is a tail on the left side and the right side, correct? There is a tail on the left side and the right side. So you can get over there. As you can see, there are some over here. It's just really hard for it to get over here because he has to keep going left, or in this case, keep going right. There's the far tail over there. It's got a couple beads in it. It's just really hard for it to get over there because it has to go. But it wants to do, on average, it would just be a wider curve. Sarah asked a great question. Suppose if we're taller, would it go wider? Potentially, yeah. But you'd still be harder to get into the tails than it would be to get in the middle. You still have a spike in the middle. You could change the curve by simply moving that funnel over to the side. So I wish they would do that, but they don't do that up there. It's all plexiglass glued together. I just find that insanely interesting. And one of the reasons I find it so interesting, I gotta fire up the PowerPoint again.
Where is that?
It's at OMSI up in Portland.
Oh.
Fantastic, fantastic little display. There's so much cool stuff up there. I want to get back to that list of data distributions. All of these things are essentially just like the machine at OMSI. And here's why I think they are. I'm making this statement. I can't prove this. Let's go with weights for full-term babies. Here, birth weights for full-term babies. If you think about how a baby develops, there are so many little factors that influence the development of a baby. Mother's diet, environmental factors, right? Blood circulation, amount of oxygen given to the baby, temperatures, whether or not you're playing Ramones when they're in the womb. So there's all kinds of factors that are going to each one of those factors. So the ball dropping into the top of that bin is like the baby starting to be developed. Every single one of those factors I just described to you is just like one of those factors impacting the fetus, if you will. So you have to figure out a way to metric them. But think about it. Let's go with more logical ones. Diet, oxygen, humidity, all those. Humidity is pretty humid in there. But you have to think about all those little factors. There's millions of little tiny adjustments that are going into the creation of something like a gas tank, or a baby, or a chocolate chip, or an M&M, or a schizophrenic eye patient's eye contact. All those little tiny effects that are flipping back and forth. It's too hard for them all to go to one side. It's too hard to be extreme on every single one of them and send it over that way, or over this way. They tend to wash out and head towards the middle with a pseudo-predictable variability. Does that kind of make sense? I love what you said, Lydia. It's too hard for it to get in the tails. But there is a trend downward towards the tails. So getting right in the middle is almost impossible, but getting close to the middle is not. And getting further and further away gets harder and harder and harder. Is that fair? Now what's interesting about it is, it froze again. What the hell? Hang on. Sorry guys. Maybe I should just not. No, it says it's running. Ha! Sorry about that. Maybe it's this. Let me close this down. Maybe I'll just leave it maybe if I just click through here. What if I do this instead? Maybe this. So, so Germany now uses the euro. Many European nations now use the euro as a common currency. Before they did that, they used what are called Deutsche Marks. This is the equivalent of a $10 bill in America. Now, we put useless people like presidents on our money. They put mathematicians on their money. Geniuses. Carl Friedrich Gauss, considered one of the 3 greatest mathematicians of all time. Take a look at what is on the 10-mark bill right there. I don't know if you noticed that or not. Not sure if you noticed. There's a bell curve on their $10 bill. This is a picture I took. I have a 10-mark bill at my house. There it is right there. It's beautiful. 10 mark. Now, of course, they use the euro now, and I'm sure there's some useless person on the euro now or some useless symbol. But the bell curve was actually placed on the $10 bill in Germany up until it went to the euro. That's how important it is. That's how prevalent it is. The normal distribution is what I want to start talking about today. I'm going to turn this off. Maybe I can reboot it and it'll correct itself. I'm going to start talking about this beautiful distribution that is tied to the binomial. It's one of 2. And I'm going to spend the last 2 weeks talking just about the normal distribution, because it is so prevalent in your guys' statistical kind of experiences. It helps answer so many questions. It helps us answer the questions